Good morning, dear students. In the previous class, we have learned about the different terms to be used in the spherical mirrors, and those terminology will be very much useful in the following lessons also. Now, in today's class, we are going to learn about the formation of images by spherical mirrors, specifically for concave mirror first. And before doing that, we have to learn how to represent the formation of those images by these spherical mirrors with the help of ray diagram. So if you want to watch it, this video, then if you want to note down these texts, if you want to make notes, then be pause this video and you try to note down, so that it may not take long time. If I read point by points or sentence by sentence, then it will take long time, so I will not read it all this. So to form images, what happen, we require what intersection of at least two reflected rays, okay, give the position of the image of the point object. So from the ray diagram, what happened, from the reflected ray, if any two reflected ray intersect, then at the point of intersection, what happened, image will be formed for that particular object. Got it? So let's see in the next page how it would be formed, the images. Okay. Yes, these are the different rules to form what the ray diagram, or to draw ray diagram. I mean, a ray parallel to, this is a principal axis. Now you know that this is a concave mirror, pole, focus, center of curvature, and this is for convex mirror. And for this convex mirror here, pole, focus, center of curvature. What is that? A ray parallel to principal axis, okay, incident onto the concave mirror, the reflected ray will pass through focus. This is the first rule for concave, okay, for concave mirror image formation, or you can say ray diagram for the concave mirror. I'm saying again, a ray parallel to what, principal axis, after incident onto the concave mirror, the reflected ray will pass through what, focus. Now, even though if this is a spherical mirror also, the laws of reflection will still holds good. See, if this is a point of incidence, at the point of incidence, the normal onto the surface will be passing through the center of curvature. Okay, it will be always pass through the center of curvature. So at this point of incidence, the normal will pass through the center of curvature like this. So incident ray, and this is a normal at the point of incidence. So angle between these two, the normal and the incident ray, we call it as angle of incidence. And the angle between the reflected ray and the normal, we call it that angle as angle of reflection. So the first law, angle of incidence is equal to angle of reflection, should also hold good in this case for spherical reflection also. Okay, but in the case of what convex mirror, what happened, a ray parallel to principal axis, after incident onto the convex mirror, the reflected ray seems to be coming out from the focus. Actually, light cannot pass onto this side, right? This is the silvering side, and this is the reflecting or watching side, this side. So what happened, a ray of light incident parallel to the principal axis, after incident onto this convex mirror, the reflected ray will not come on this side, rather it will be reflected like this, back to this same medium. Okay, so this reflected ray seems to be coming out from focus, right? From focus, it seems, when you look from this side, what happened, this reflected ray seems to be coming out from somewhere here, from the focus. Got it? Yes. The second one, yes, a ray passing through focus. This is just the reversibility of light. Okay, reversibility of light, incident light, reflected light. If you make this reflected light as the incident, then this incident ray which was there will be the reflected light, it will be reversed. Okay, reversibility of light always holds good. So what happens if you make reverse this light? That means this will be met as the incident ray, and the incident ray which was there will be the reflected ray now. So what happened? What is the text saying? If a light incident onto a concave mirror passing through focus, after incident onto the concave mirror, the reflected ray will be parallel to the principal axis. That is what it is said here. A light ray passing through focus after incident onto the concave mirror, okay, the reflected ray will be coming out or emerge out parallel to the principal axis. Same is the case in this case of what convex mirror. A light ray which is supposed to pass through focus. Supposed to pass means which it moves or which it incident, okay, along this line so as to pass through this focus, but light cannot enter through this as the reflecting surface is here. This is a watching side. So a light ray which is supposed to pass through the focus of a convex mirror, after incident onto the convex mirror, the reflected ray will be emerged out, will be or going out or reflected back parallel to the principal axis. Got it? Yes. Next. Now a ray, okay, which passed through center of curvature, the incident ray which passed through the center of curvature after incident onto the concave mirror, there will not be no reflection at some angle. Rather, that part will be also the part for the reflected ray, but in the opposite direction. That means there will not be any bending in this case. Okay, a light ray which passes through the center of curvature after incident onto the mirror, the reflected ray will pass through that part in the opposite direction. Got it? Here also same thing. A ray, in the case of convex mirror, a ray which is supposed to pass its center of curvature after incident onto the convex mirror, the reflected ray will move in the same along the same direction, along the same path I should say, but in the opposite direction. Got it? Why it is so? Because this is a normal. Suppose if a light ray, when we talk about that of plane mirror, okay, when we talk about that of plane mirror, is it not working or what? Yes, when the in the case of plane mirrors, okay, plane mirrors means incident on the plane surface. Suppose if this is the reflecting surface, and if this is the normal, got it, like this, and what happens if the incident ray falls on like this? Suppose this is the incident ray. What is wrong with my mouse? It is not good, no? The reflected ray will be coming out like this. So what happened? This is the angle of incidence, and this angle will be the angle of reflection, right? So incident ray, reflected ray, and this is a normal. Suppose if it happens to incident like this. Suppose this is the mirror, got it, and suppose if this is a normal, and normal at what? Normal to this surface, reflecting surface, and if your incident ray pass through these lines, same normal, okay, if your incident ray pass through this, then naturally where will be the reflected ray? Yes, reflected ray will be along the same line but in the opposite direction. Got it? That is the case for this, in the case of what? This one. Yes. Sorry. Now what happened? Yes, that is what I have said. As I've told you that at the point of incidence, the normal will pass through the center of curvature, right? So this is the normal at this point what happened, a line passing through this point and a center of curvature, this is a normal. So if a light is incident onto the normal, the reflected ray will also move along the normal. That is what same thing here in the case of reflection from the plane surface. Same is also here. If this is a point of incidence, then this point of incidence and the center of curvature, that line will be the normal. So this line is normal. So a line incident onto the normal, the reflected ray will also pass through the normal itself, right? That is what it is here. And the last one, suppose if an oblique ray, not parallel to the principal axis, not passing through the focus, not passing through the center of curvature, if a ray of light incident onto this pole with some angle, that means if this is the incident ray, point of incidence I mean, then the normal at this point of incidence will be this line, the principal axis, right, passing through the center of curvature, right? So this is a principal axis. So your angle of incidence, okay, this is the angle of incidence. So if an oblique light ray what incident onto the mirror having some angle I, then just to hold good the laws of reflection, what happened, the reflected ray should also emerge out, making some angle equal to that of the angle of incidence. So this angle will be equal to the angle of incidence, so that this will hold good the laws of reflection. Angle of incidence is equal to angle of reflection. Got it? Same is the case in the case of what, your convex mirror also. Now let's see for the image formation by spherical mirrors. I will show you first in the form of table, and then we will have to go to that ray diagram, right? Now let's see for concave mirror first. Convex mirror we will do later on in the next class, right? Now this one for concave mirror. Now let's try to bring this your object from far away from the center of curvature. We call it at that as infinity, and let's try to bring the object closer and closer and closer and closer toward the mirror, right? Yes. Now what happened, the image formation, is like this. If the object is placed beyond center of curvature, that means in some textbook this may be written as infinity also. Okay, so if the object is placed a little bit far away beyond C, then we can assume that that is at infinity. So if the object is placed at infinity, then the image will be formed where, between C and F, between C and F. Got it? In general, by sign convention, mirror or lens is placed on the right hand side and the object is usually placed on the left hand side. So when the object is placed beyond center of curvature, what happens, image will be formed between C and F. If the object is placed like this, upright above the principal axis, then the image will be formed somewhere here, there, like that. Got it? So what happened, between C and F, image will be formed between C and F. And what will be its nature? Let's see. It will be real, no doubt. Image will be real, inverted and diminished. Okay, if at the center of curvature, if the object is placed at the center of curvature, then the image will be formed at the center of curvature like this, inverted. So what will be the nature? Image, object at center of curvature, image will be also at center of curvature. And the nature of the image will be what? It will be real, inverted and of the same size. Got it? Same size means the image size will be equal to the size of the object. Between C and F, what happened? If the object is placed between C and F somewhere here, then the image will be formed beyond C. Okay, and the nature of the image will be what? It will be magnified, it will be real, inverted and magnified. Between F and P, that means between the focus and the pole of the mirror, if it is placed somewhere here, then what happened? The image will be formed what? Behind the mirror. Okay, behind the mirror, it will form somewhere here. Got it? And the nature of the image will be what? It will be erect, virtual and what? Magnified. Got it? And in front of the pole for convex mirror, or this will be done later on, okay, in the next class, not now. Let's see for this different formation of the image, how these images are formed, okay, by ray diagram. So let's see in the next slide. So see, if the object is placed at infinity, object placed at infinity means object placed beyond center of curvature. If the object is placed beyond center of curvature or infinity, you can say, then what happen? A ray of light from the tip of this object A, what happen? A ray will be coming out parallel to the principal axis, and after incident onto that mirror, the reflected ray will surely pass through focus. So what happened? Another ray may be also coming. Don't think of this only 2 or 3 rays. There are many rays coming from this object, or even from the same point also. A ray coming from this point, what? It is not only this ray. Okay, there may be many rays coming from the same point like this. Got it? And if those rays coming from here, another ray coming from here parallel, as it is far away, what happen? All the incident ray will be taken or may be taken as parallel, and all those parallel light rays after incident onto the mirror, what happen? The reflected ray will pass through the focus, right? And the intersection of that reflected ray will give you what? The image. So in this case, if the object is beyond center of curvature or at infinity, then the image will be formed at focus, right? And the nature of the image will be what? Real, inverted, and highly diminished. Now next is the case when the object is placed beyond, little bit beyond center of curvature like this, not at infinity, beyond what? Center of curvature, little bit beyond center of curvature. Now AB is the object. Okay, and from the tip of the object A, let's take it that 2 rays incident onto this concave mirror. A ray parallel to the principal axis, after incident onto the mirror, it will pass through where? Yes, focus. It will pass through focus. Another light ray coming from this same point A, passing through the center of curvature, after incident onto the mirror, the reflected ray will pass along the same path but in the opposite direction, right? This was a rule that we have learned, the last rule I mean. Got it? So what happened? This point is the intersection of these 2 reflected ray, one from here, another here reflected. These 2 reflected ray intersect or meet here, so the position of the image for this point will be here at this point. So now if you take it another point somewhere here, okay, if you take it another point somewhere here, then similar to that, what happened? A light ray reflected like this, parallel incident parallel to the principal axis, after incident onto the what? Mirror, the reflected ray will pass through the focus like this. Got it? And another light ray coming from here, okay, this is the incident ray, one arrow mark should be there, and this is a reflected ray, one arrow mark should be here like this. For this, from this particular point, as we have taken from here, one ray parallel to the principal axis, another passing through the center of curvature. Likewise, from this point also, one ray parallel to the principal axis, another ray passing through the center of curvature like this, passing through the center of curvature. It will be reflected back again along the same path. In this direction, it will be reflected back along the same path again in this manner, right? So what happened? The 2 reflected ray meet somewhere here. Got it? In that way. So likewise, for every point here, there will be also a corresponding point onto this image. Got it? So for every point onto this object, there will be a corresponding point onto this image. If you take it one point somewhere here, the image of this object point will be also somewhere here, okay? And if you take it at the base, near to the base like this, somewhere here, then the image will be also somewhere here, corresponding to that object somewhere here. Got it? So the image will be formed in that way. So the nature of the image for this object placed little bit beyond center of curvature will be what? Between C and F. It is inverted, okay, and so it will be real. Why real? There are 2 type of images. One is real image, another is virtual image. So what happened? How these real images are formed? Real images are formed by the real intersection of the reflected ray. So real images are formed by the intersection of 2 or more real reflected rays. If these one of the reflected ray is virtual, then what happen, the image form will be surely a virtual image. Got it? Yes, real image can be obtained on the screen, whereas virtual image cannot be obtained on the screen. So whatever we see in the dressing mirror, okay, in the dressing mirror, what happen, whatever we see on the mirror, plane mirror, can we form image of our own image, our own body? We can't, no, it cannot form image of our own body. So what happened, the image form on the plane mirror or dressing mirror is what, virtual, because it can't obtain or it can't form image onto the screen. Now this one is for the object placed at the center of curvature. AB is the object which is placed at the center of curvature, and now two image incident ray, one parallel to the reflected ray passing through focus. After incident onto the mirror, it will pass through the focus. Another ray passing incident passing through this focus. After incident onto the mirror, it will be reflected parallel to the principal axis. So the two real reflected rays intersect here at this point. So what happens, your image will be formed here at the center of curvature. So when the object is placed at the center of curvature, image will be formed at the center of curvature, and the nature of the image will be what, it is what, real, inverted, and of the same size. Got it? And if the object is placed still closer toward the what, mirror, so let's keep the object near the center of curvature and the pole somewhere here. What happened, the two rays, one parallel to the principal axis, after incident onto the concave mirror, it will pass through focus, no doubt. And another ray which is what, passing through this direction, that means after the reflection, what happened, it will come out to the center of curvature. Naturally, this is the, if this is an incident ray, then this is the normal. A light ray, okay, incident onto this mirror such that it is normal to that mirror. I mean, the incident ray is normal to the plane of the mirror here. Got it? The reflected ray will be coming out along the same path but in the opposite direction, and it will meet somewhere here. Got it? Instead of that ray, also you can draw like this also, a light ray passing through this center of through this focus. After incident onto the mirror, the reflected ray will be coming out parallel to the principal axis like this. So one ray like this passing through the focus, okay, passing through the focus like this. After incident onto the mirror, the reflected ray will be what, coming out parallel to the principal axis, so that it will reach at the same point like this, in this manner. Got it? So what happened, we can draw any of the ray diagram by following those rules that we have done earlier. Okay, so like that we can have this point as an image for this object point A. Got it? So what happened, the formation of the image will be at this point, that means A prime, B prime. So in this case, what happened, when the object is placed, when the object is placed where, between C and F, then what happened, the image will be formed beyond what, center of curvature, and the nature of the image will be what, these two rays are real rays, real reflected rays. So real reflected intersection of real reflected rays will form what, real image. So the nature of the image will be what, it is what, real, inverted, and enlarged, or you can say magnified. Got it? Yes. Likewise, if you place at the focus, if the object is placed at the focus, then what happened, the image will be formed at infinity. These two reflected ray will meet at infinity, far away there. Got it? So what happened, if the object is placed at the focus, then the nature of the image will be what, it will be real, inverted, and highly enlarged. That means the image will be very large if it is meet at the infinity. Okay, these two rays, right? And now if the object is still bring closer toward the mirror between F and P, if the object is placed between F and P, then what happened, the image will not be formed onto this side of the mirror, rather the image will be formed behind the mirror. Okay, so one ray Okay, incident onto this, reflected back, and this reflected ray seems to be coming out from somewhere here. Seems means what? Virtual. Actually it is coming out from here, but while we watch from this side, if your eye is somewhere here, then the image seems to be coming out from somewhere here like this. Got it? So in that way, so we call it as what we say as seems to be. Why? Because it is not actually light. Actual reflected light starts from the mirror onward. Okay, reflected back from the mirror, not from behind the mirror. But we can assume that, or we can think that it seems to be, it is coming out from behind the mirror. And another ray which follow the last rule, making some angle and equal to angle of incidence, the reflected ray will be moved back like this. The reflected ray for this also seems to be coming out from behind the mirror. Okay, seems to be coming from behind the mirror. So these two virtual, we call it these as virtual rays, seems to be coming. Okay, so these two virtual rays intersect and the image will be formed at the point of intersection. So for this object, image will be formed here. Okay, and so the nature of the image, when the object is placed between F and P, that means focus and the pole, the image will be formed behind the mirror, and the nature of the image will be what? It is virtual. If the image is virtual, it will be erect. So virtual, erect, and magnified, we can say. Got it? So now I will tell you one thing, very important thing. Now at the very beginning I told you that reversibility of light holds good, right? Reversibility always holds good in the case of light. Suppose if the object is at infinity, image will be formed at focus. Now if the object is placed at focus, then the image will be at infinity. That is what it is having here. Got it? When the object was at infinity, image is at focus. So now you change this object and image. If this point is met for object, then the image will be at infinity. That is what here. Got it? If the object is beyond center of curvature, image is formed at what? Image is formed between C and F. So if this object is placed between C and F, that means where? This one. If the object is placed between C and F, the image will be formed beyond center of curvature. That is what? Image is formed beyond center of curvature. Got it? Yes, you can think of over like that just to make simpler. Got it? Okay, thank you. Let's stop it here, and we will try to do in the next class the image formation by spherical mirrors, and the remaining things that we need to do for sign convention and all we will have to see in the next class. Got it? Okay, thank you.